Welcome back to GateXAIML. So today we'll start with continuous probability distributions. In that the first one is continuous informed distribution. Previous lecture you have seen the discrete informed distribution. The same way for continuous random variable, how you define a continuous informed distribution. The same way you define it between an interval a, b. So the discrete case you have the bars and or the histograms that you draw because it is discrete. But in continuous, if we take the interval a, b, so we will not have points here between a to b. Instead, you will have complete area bounded under the intervals a comma b. So this is the probability density, the uniform distribution, that is continuous for continuous random variable. How will you define it? The PDF is defined as 1 divided by b minus a in the interval a to b. The expected value remains same, that is a plus b by 2. For the variance, it also remains same, only thing is we are not adding 1 here, b minus a whole square by 12. There is no concept of spacing here, the d value, because it's not discrete. So anyhow, you will directly integrate here, no summation. And the cumulative distribution function CDF is given as capital F of x equal to 0 if x less than a, or x minus a by b minus a in this given interval a b, else it is greater than 1. What it means to say, below this is 0 because it is not under my curve. So above this it is anyhow 1 because at b itself it is the accumulation is 1. Accumulation means go on adding it by parts. So that simple thing. So where will you apply? Whenever you see the word continuous and then the probability is equally likely between the intervals a b, then you can apply continuous form distribution. Let us take simple example. The commuter waits for a bus that arrives at a random between 0 to 20 minutes. So they are saying 0, A is 0, B is 20. That's so the uniform distribution. So it is continuous. Let x be the waiting time in minutes. Find the PDF of x. PDF of x is given as what? F of x equal to 1 by b minus a in this given interval. So that is equal to 1 by 20. Right? Now, what is the second thing? Probability that the commuter waits for more than 7 minutes. P of x greater than 7, more than 7. So it is nothing but what? Integral of, here you need not do 1 minus p of x equal to less than equal to 7 because continuous you can directly integrate. So we know the boundary here, 0 to 7 to 20. 20 is the upper limit. So greater than 7. What is the f of x? 1 by 20. So dx. To integrate this will be x divided by 20 in the interval 7 to 20. So this comes out to be 13 by 20. Next. You can also solve using what? F of x, okay, that is CDF. Now the expected waiting time and variance, E of x is equal to a plus b by 2, that is 20 by 2 is 10. Then variance is given as b minus a whole square by 12. So that is b minus a is 20. 400, 20 square is 400 divided by 12. This is the answer. A simple question. Now, second one. The thermostat records temperature uniformly between 10 degree and 50 degree. So, they given the interval a equal to b and b equal to a equal to 10, b equal to 50. Let x, random variable x, be a temperature. Find mean and variance of x. So, we know it follows uniform distribution. So, mean is c by a plus b by 2. That is 30. Then variance is given as b minus a whole square divided by 12. So 40 square by 12. Then second one, probability that x is less than 30. So x is less than 30 means integration. So what is the function here? 1 by b minus a. B is 50 and then 40. So dx. Now what are the intervals? Be careful here. Intervals, what is the upper bound? 30. What is the lower bound? Not 0, because it is in the interval 10. So 10 to 30. This will be equal to 30 minus 10 divided by 40. That is 1 by 2. Okay. Next, the customer support call lasts uniformly between 2 and 12 minutes. Let x be the call duration. Find the PDF of x. So f of x equal to 1 by 12 minus 2 is 1 by 10. Second, the probability that a call lasts between p of 4 less than equal to x less than equal to 9 minutes is equal to integration of 4 to 9. Okay, because it is from 2 to 12, so I can start and take 4. It is in between 2 and 12. 1 by 10 dx. This will be equal to 9 minus 4 by 10. 1 by 2. Next, expected call duration E of x is equal to a plus b by 2. So this is 14 by 2, that is equal to 7. Okay. Now we'll see one more example. Let x is uniformly distributed in the interval 0 4 and y is uniformly distributed in the interval 0 to 6. Both are independent random variables. Find the probability that x plus y is less than 5. So they are given x and y, that means what? So it is joint distribution. So given the joint distribution, and then they are asking you to find the first thing, p of x plus y is less than 5. You can calculate the f of x for this, f of y for this, that is probability distribution of this, and then apply the joint distribution and then calculate this value. But since it is a uniform distribution, you can easily imagine the curve, right? It's just a rectangle. The area bounded by uniform distribution is a rectangle. So it can directly solve this such kind of questions. So let us take this curve, what it means. So this is my x and this is my y. What is the area bounded by x? Start from 0, it goes till 4. What is the area bounded by y? It is 0 to 6. Now what is the area bounded? The joint density. Joint density is this. So entire area is equal to what? Entire area bounded by these two distribution is the rectangle area, right? This entire rectangle. This entire rectangle is the area bounded by these two density functions. So this is my area. How will you find this area? Area of rectangle is length into breadth. This 4, this is 4, this is 6. So 24. Now, this is a line x plus y less than 5. That is what you have to find the area. What is the probability of this? Means out of this entire area, this 24 units, what is this area? So there will be numerator. That should be less than 5. So let's say x plus y less than 5. You can write it as y is less than 5 minus x. So what is the area bounded by 5 minus x, which should be less than this, less than 5 minus x. So what is this area? I can write it as the area is equal to integration of 5 minus x dx. What is the area bounded? This for the intervals. What is the interval of x? X is 0 to 4, right? That's what they're given. So now you integrate under this area. So basically what they are saying, this is what you get. This is the x plus y less than 5. When x is 4, you apply this. y is always less than 5 minus x. So starts from say somewhere 5 less than 5 and then till 4. This is the line x plus y less than 5. So this is the area they are asking you to calculate, the area of this triangle. So just I got this equation. If I integrate this 0 to 4, so I will get the area under this line x plus y less than 5. So this comes out to be 5x minus x square by 2 in the interval 0 to 4. So that is equal to 20 minus 8 is 12. So what is the probability now? Probability of x plus y less than 5 is equal to, this is what you have found, this is the area, it is area is 12. So divided by out of this entire box, this is what is the probability we want to find. So out of 24, that is 1 by 2, the answer. Now similarly, P of x greater than y. Okay, so same concept. So entire area bounded by these distributions is 24. What is the area bounded by this line x greater than y? So let us, for simplicity, convert it into y. If I make it y, y should be less than x. X is greater than y means y should be less than x. So again integrate, the area under this will be equal to x is again 0 to 4. This is x dx. Okay. So this will be x square by 2, the interval 0 to 4 is 16 by 2 is 8. What is the probability of x greater than y is 8 divided by 24. That is equal to 1 by 3. So I have to solve. Okay. When you apply the joint density function also, you will get the same answer. Only thing, it becomes a little bit bigger to solve. Next, let x be uniformly distributed over minus 2 to 5. Find the CDF of x and the median of x. Okay. What is the first CDF? CDF is equal to 0 if it is a is, if x is less than a. Okay, so less than a. What is a equal to minus 2, b equal to 5 here. So if it is less than minus 2, then it is 0. If it is, should be 1 if it is x is greater than b, that is equal to 5. So what is in between? X minus a divided by b minus a in the interval minus 2 to 5. So what is this x? X minus, what is a? A is minus 2, minus minus plus 2 divided by b is 5. 5 plus 2, 7. This is the CDF. Okay. Thank you for watching. Please like, subscribe and share. We will continue with exponential distribution in the next lecture. Thank you.